This is a short introduction to the Uranium circuit editor. While at first sight, Uranium is a simple drag-and-drop application, we have built into our editor a number of shortcuts that will allow anybody to create with ease large and complex quantum circuits. First things first, you probably want to start by picking a gate and dragging it into the circuit. Now, you might ask, do I have to do that for every gate I want to add to my circuit? Fortunately, the answer is no. Once you have added a gate, you can easily duplicate it. If the Shift key is pressed during drag and drop, the original gate is not removed and an identical copy of the gate is placed at the drop location. If the Alt key is pressed, a horizontal or vertical array of identical gates will be generated. By executing a click while the Control key is pressed, a cell in a circuit will be selected. A second Control click will select a rectangular area in the circuit. Once you have selected one or several cells, the Control C, Control X, Control V, the Escape, and the Delete keys work, as they are expected to work in any editor. Most of the actions in the editor can be triggered by a single click. Pressing the S key while executing a single click on an existing gate allows the user to quickly switch one gate to another. The most obvious method to delete a gate is from the Gate pop-up dialog, prompted by executing a single click on the gate. The same pop-up dialog allows inserting a new step or a new qubit in the immediate vicinity of the gate. You can delete a gate a bit faster by pressing the D key while clicking the image of a gate. A third option to delete gates is to pick one and drag it outside the editor area. The latter is not my favorite shortcut, but some users find it very natural. Controls can be added to a gate by dragging a control icon from the top of the left panel. Controls can be applied in the Z basis, but also in the X and the Y basis. You can add as many controls as you need. A somewhat faster method, to add multiple controls at once, is using the control editing dialog that can be opened from the Gate pop-up dialog. Clicking on a controlled qubit opens a pop-up dialog from which control settings can be adjusted, or the control can be removed entirely. A faster method of removing a control is by pressing the D key while clicking any control placed on some gate in the circuit. When the S key is pressed while clicking on a control qubit, you can toggle or switch between the two possible states of control in whatever basis the control happens to be initialized. Of course, you can adjust a control qubit position by dragging it to a new spot in the editor. If the Shift key is pressed during the drag and drop action, the original control is not removed and a copy of the initial control is placed at the new drop position. A double click on an empty cell in the circuit will open a dialog that allows removing the corresponding step or qubit from the circuit. A central feature of the circuit editor is the ability to compose circuits. New gates can be created from existing circuits, which can be reused to create more complicated circuits. A useful shortcut when constructing such circuits is the replicate gate feature, which permits creating circuits where a composed gate can be replicated several times in a row by assigning possibly different gate powers, different numbers of controls, or different control states. Please check out our projects gallery to see several examples where this feature allows rapid implementation of some very well-known quantum algorithms. The Uranium circuit editor implements a very large collection of quantum gates, some of which are not available elsewhere. In case you are ever confused about what any given gate means, you can use our Help facility by selecting a gate in the Gates panel and then pressing the Help button in the toolbar. If you unselect the gate from Gates palette, you will find some general help information on how to use our circuit editor. In case you have any further questions, please do not hesitate to contact us on Discord or via the contact link on the main page of our platform. Since we use a simulator, it does not make much sense to sample the state vector when we show our results. We instead show an array of probabilities corresponding to each possible state. When measure gates are added to a circuit, their role is not to make a measurement at the end of the simulation, but to indicate the subspace of the Hilbert space for which results will be displayed. When no measure gates are present, results for the entire Hilbert space covered by the circuit are shown. Each measure gate has associated a classic bit into which results will be projected. When you add a new measure gate to your circuit, a classic bit is assigned automatically. In general, this has the same index as the qubit where the measure gate is placed. This is true even if you copy and paste a measure gate or duplicate it by pressing the Shift key. There is one exception to this rule: if you use the Alt key to generate an array of gates from a given one. In this case, The initial gate is used as a reference and classic bits are incremented one by one starting from the classic bit index of the initial measure gate. You can of course set up any classic bit index to a measure gate as long as the bit index is not larger than the maximum qubit index. Measure gates must always be placed last for any given qubit. If multiple bits share the same classic bit, then simulation results for that bit is given by addition modulo 2 of individual measurement results. You can press the tooltips button on the toolbar to check the current configuration of measure gates. When simulating a circuit, the gates in the circuit editor are applied from left to right, which is the generally accepted convention. Also, visually, the circuit editor has an implicit ordering of bits from top to bottom, where the qubit with index 0 is placed on top and the qubit with the highest index is placed at the bottom of the editor. You can press the tooltips button to verify this ordering. A valid question to be asked is how should the state vector be represented for a quantum register that consists of a given set of qubits? The state can be represented as a tensor product of qubits where the first, topmost qubit in our editor, is placed at the start of the tensor product as the leftmost qubit while the last qubit in the editor is placed in the rightmost position of the tensor product. This ordering feels very natural, and perhaps this is the reason it is being used in most physics textbooks. We will refer to this ordering as big endian ordering. However, using this convention puts the most significant bit on the right of the tensor product and the least significant bit on the left. This can be a problem if you want to cast the binary representation of a state vector to a decimal number, because for binary numbers the most significant bit should be put on the left, and the least significant bit on the right. For example, here we have a circuit adding 1 plus 1, with carryover. If I switch to the binary representation of the state vector from the checkbox on the toolbar, and if you look at the output state which has a non-zero probability, it seems at first sight that 1 plus 1 is 1. However, when I uncheck the big endian ordering checkbox on the toolbar and switch to the little endian ordering, I will get the correct result. Many commercial quantum computing platforms, like for example Qiskit from IBM, Forest from Rigetti, or Q-Sharp from Microsoft, use the little endian convention. If you choose to work in the little endian mode, which I have done right now, I need to reposition the Audemars gate to recover the original probability distribution. The quantum Fourier transform gate is configured to work with both the little endian and the big endian conventions. In the end, I would like to add just a few words. In case you liked our circuit editor and will use it either to study or to perform research on quantum algorithms, we would like to hear from you. Please do not hesitate to contact us either directly using the link on our front page or, even better, on our Discord channel, regardless if you have a usability question, have found a new bug, or have a feature request. Thanks a lot and happy editing!